Thank you so much for giving me this opportunity. So my name is Intan Puri Rahayu. You can call me as Puri. I come from Indonesia. Actually, I come from mechanical engineering background, but currently I'm working as educational technology officer of Korea. I have been involved in education world since 2019 as a coach and maker related to hands-on experience and actively to share about STEAM and maker activities like global innovation field trip like this conference, and then also maker fair. And then at this moment I'm so interested in developing program that related to industry revolution 4.0 and STEAM, especially for kids and youth. And for now, I would like to share about one of my project that I did when I was a student in university that related with mechanical engineering. So the title is the structural analysis of the boogie frame. So I did the analysis for the LRT that is affected by gradient resistance, curve resistance, acceleration, and also the emergency braking. And why I did the analysis, because this one is one of the learning value that I did when I kept when I was a student in university. I learned that the engineer is also a designer, and this is the one of the question: how do we know if the design of our part is safe enough? And I think it's also the difficult question that many designers ask themselves. And when as also one of the learning value that I get is when a part fails, it involves, of course, a risk for the life of people, but also a huge financial loss when for the company who created this part. And that's why finite element analysis, or we call as FEA, is so important for a company who design the product. And then to assess the safety designer, or we call as engineer, need to do the simulation that will help in understanding if a design is safe enough or not. And then this is the simulation. I hope that it can help to understand why a design fails and where it fails and how to improve it. And the first one that I did when I tried to do the simulation, that I need to collect the data from the company. This is the part of the LRT. The first one we call as motor car. It consists of the engine. And then the next one is the trailer car. Trailer car is the part that load for the passenger. And I also get some of the specification that I need for doing the simulation, that consists of design, and also operational speed, deceleration, curve radius, and also maximum slope. And what is actually boogie? So this is the boogie. Boogie is a component of the train. As you can see here is the wheels. The boogie is the component between wheels and also the car body. So the car body is the part that load for the passenger, and this is the part for loading the passenger. And then this is the wheels, and boogie is part between car body and also wheels. And one of the part on boogie frame that I want to analyze is boogie frame like this. And then this is the second one that I did when I want to do simulation. After I collect some of the data, I have to formulate the problem. So I want to analyze the resistance. What is actually the resistance? Resistance is a combination of the force that works against the movement of the train. Why I want to calculate the resistance? Because I need to measure more accurately to estimate the force to be as close as possible to the real value, so that I can make sure that this design, this structure is strong enough, and then we can say this structure is safe. And what is actually the function of the boogie? It's the structure that should be able to support the car body for the loading, and also resist the drag force, and then also the resist for the drag force, and also the for maintaining the stability of the train. And this is the 3D model of the structure of the boogie frame. I try to define some of the load that happen in this structure in three axes. The first one is X, and also Y, and also Z axis, and I draw the force that might be accepted or received by the boogie frame during the track. And also this one is some of the load case that I try to define for formulating the problem. I try to define 4 load case, as you can see here, with the different condition. And then the next one, after I did the formulation for the problem, the next one I have to do the manual calculation, and this is the 2D model of my simulation, and we call it in engineering as the free body diagram. And I have to define the force that happen in the wheels, on the wheels, and then also boogie frame, and then also the car body. The car body is the part for loading the passenger, and we have to also see the part or the free body diagram that happen in side view, and then also top view, and then also the front view. And this is the one of the example for 5 analysis that I did. After I did the calculation or manual calculation, then I have to define the load case, or I call that I try to do the calculation for some of the load case in X, Y, and also Z. And this is the result after I did the manual calculation. And then after I did the manual calculation, the next one is I have to insert the structure into the engineering software to have the simulation like this. So I use the ANSYS software, as you can see here. But the first thing that I did before I do the simulation is I have to simplify the structure. So actually the real structure is not that simple like this, because I have to make sure that this structure is compatible enough for doing the analysis. So what I did before I insert for analysis is I remove or delete some of the parts so that it can be compatible, and then it can be analyzed by the software, the ANSYS software like this. And then after from the simulation by using the engineering software, I have to compare so that I can say that the result is verified by comparing 2 results from the manual calculation and also the simulation. So this one is the value from the manual calculation, and then the next one I also get the value from the simulation by using engineering software. The result will be verified if the result from manual calculation is similar with the result from simulation by using the engineering software. And then the next one, I try to input some of the value that I need for comparing or analyzing. And after I did some of the simulation, and then also I have to conclude. So I have to have the conclusion, and then this is the result that I get is the maximum stress earned when the LRT is affected by curve resistance with the minimum curve, and then I also get the speed when the LRT is operated at 17 meters per second. And then the final result, I can say this boogie frame is safe. And I can also say that this structure is strong enough so that it can be safe when it's operated in the track. So I think that's all that I can say about my project. I hope that it can be inspired to everyone when later maybe want to continue this analyzing. Thank you so much.
Take some walk down memory lanes as an engineer.
I am sometimes asked, what do really good engineers do? And from now on, I will be showing them your video, your presentation. That was excellent. That was absolutely excellent. That was
actually, it was just an emotional memory lane, walk down of memory lane, because I've done pre-engineering as well. And those numbers and the way she was explaining, and I was like, wow, I wish I could know this better when I was when I was doing my pre-engineering, right? Could have been much better.
Thank you.
That was
sometimes I wonder these kids, I mean, the people of this age, what sort of lovely facilities and everything is available to them, and we just missed everything.
That was very, very impressive. Very impressive.
Indeed.
Have you shown that to other people? Your presentation?
Sorry?
Have you shown this to your professors from school? I think they would be very proud of what you have done.
Actually, not yet for this presentation, but later maybe I can also share, so that maybe I hope that later I can also have like the like publish my article. So in international, maybe I hope that later I can also publish my my final project later. And maybe sometimes that some of the students want to continue the simulation. So maybe I try to use this method maybe for the next student maybe wants to use the other method by using the same structure. I hope that it can also possible for maybe the other one who want to continue this project.
And what are some other things, I mean, what other areas where this boogie formula simulation is also applicable? I mean, do you have some other examples where we can just apply this formula?
So actually, when we did this simulation of the LRT, my focus is about the boogie frame, but I also have the other. We also have the other researcher who analyze the other part of the boogie. As I mentioned, that boogie consists of a lot of part of it, but the part that I want to focus is just the frame. We have a lot of part on it. But the other researcher also did the analysis for the other part, so that we also have the discussion on how we make the LRT can run safe when it load the passenger.
Very good. Very impressive. Very, very impressive.
Right.
Inspirational. Thank you very much, Puri. Thank you. Thank you.
Thank you, Puri. Okay. Keep doing the good work.
Thank you
I'm
so
glad
much.
we have engineers like you around in the world. We're getting safe hands.
Okay, thank you so much.
Bye.
Bye.